Hey, Delaney and Chloe, we are starting chapter 4. We're doing probability. I said this chapter is where we kind of slow down a little bit. I feel like we've gone pretty fast so far doing the last 3 chapters, but this one we slow down a little bit, mainly because chapter 4 has 5 sections to it, and it takes a little bit of time to get through some of those. Like this is like a lot of pages for section 4:1. So here we go. Some of this is going to be fairly easy, like just what is the probability of rolling an even number on a dice, right? Like not too bad so far, okay? That's where they kind of start us with. So part 1 is basic concepts of probability. I'm going to look at example 1. It says researchers have made this claim that, here's the claim, we have developed a gender selection method that greatly increases the likelihood of a baby being born a girl. There's literally people that are out there studying this right now. I don't know why, when we're like trying to cure cancer and all the things. Like, why are we devoting our time and energy to like this? But evidently people think it's important, so whatever. They want to increase the likelihood of a baby being born a girl. So the method of gender selection has no effect, is the hypothesis. We're assuming that it didn't work. And then if we get some really abnormal results, then obviously it did do something. So we want to see if our results are significantly different than 50% births for girls, right? 50% is like the cutoff mark. So if we go over here, this is what we have going on, right? Different gender selection methods. So they had test result A, okay? So they gave these women this pill or something, I don't know, and this is the result that they got. They got 75 girls and 25 boys. Holy moly. That's a big split, right? I'm going to guess that whatever A result is maybe doing something, right? Whatever this pill is doing. They say the chances, write this down. This is the chances of random occurrence. Okay? The chances of this happening randomly without any intervention is 0.0000, like a bunch of zeros and a 3, right? The chances of this occurring without any intervention is 0.000, a bunch of zeros and a 3. Hold on, my computer's going to die if I don't plug him in. I got to figure out where my cord is. Right? Oop. Okay, so is it, if this is the scenario for test result A, and that's the chances that it's going to occur just randomly in nature, is it likely that this pill is doing something? Yes. Like, I'm going to guess that this pill is causing something to happen. Okay? B, though, if we look at those results, we had 55 girls and 45 boys for test result B. That's a more even of a split, and the chances of that occurring just randomly by random chance is 18%. It has an 18% chance that split is going to happen. Okay? So is that likely that test, that pill letter B caused this to happen? Probably not, right? Because that split probably occurred anyway, right? 18% chance that it's going to occur. Okay? So that's the thing. When we're looking at probability, we're looking at like, okay, is this causing something to happen? Is our drug causing some results, right? Okay. Research and developers, people that go into research and development for, like, let's say in Clay Center, the Animal Research Center, there's people that like make oodles of money that work there that just crunch numbers all day long, and they figure out like whatever treatment that we gave to these pigs this week, is that causing something to happen? Are we seeing a decline in health when we administer this treatment to these animals? Whatever, right? There's people that work in research and development that are doing that all day long, okay? All right, basics of probability. What is an event? I'm going to say one trial. Okay, one trial, whether it's a roll of a dice, roll dice, spinner, etc. Okay, that is one event. Okay, one event. Roll dice, spinner. Okay. All right, a simple event is when there's only one category involved. Okay, so I'll explain that, and I'm going to put compound event here. Compound event. One category. So I'll explain to this like what this is. I'll say two or more categories involved. Okay, so like a simple event might be the chances of me rolling a 3. A compound event might be rolling a 3 or a 6. Does that make sense? Compound is 2 events that are happening. I want to like look at those 2 different categories versus a simple event is like I want to know just the chances of rolling a 3. Make sense? Simple event, compound event, we're like elaborating on what the outcomes could be. Okay? And then let's talk sample space. Okay, I'm going to list out sample spaces. Sample spaces is the list of possible outcomes. Okay, so let's say flipping a coin. What are the options that I could have for flipping a coin? Heads, tails. Okay, let's say rolling a dice.
1 through 6.
I do these little like squiggly brackets. 1, 2, 3, 4, 5, or 6, right? Okay, now I'm gonna get a little bit more intricate. Ready? Let's do the sample space for 2 coins. What's the sample space for 2 coins? I could get a heads and a heads, right? I could get a heads and a tails. Tails, heads, or tails, tails, right? Those are my like list of possible outcomes. Got it? Here eventually we'll do like 3 coins. What are the chances of getting 3 coins? Or like what's the outcomes for 3 coins? We have to list all of those out. Okay, that's an even longer list. Do you see how our list gets a little bit more intricate? This is a compound, okay? Because we're doing 2 coins. We're looking for 2 outcomes. These are simple events, 1 coin or 1 die. We're not looking at 2 things happening, okay? In fact, in this next one is where we're looking at 3, I think, okay? So simple events. In the following, you use B to denote a baby boy, G to denote a baby girl. So if I am having a single birth, my sample space is B or G, boy or girl, right? Okay? Now, if I have 3 births, I have this going on. All right? How many outcomes or how many lists are in that sample space? A lot. How many? 8. Why 8? If you have 1 baby, 1 slot right here, 1 baby, how many possible outcomes for gender? We're keeping it simple. Don't go there. How many possible genders are there for 1 baby? 2, right? But if I have 3 babies, I have 1, 2, 3. How many genders could the first baby be? 2. How many babies could the second gender be? Blah, blah, whatever. 2. And the third one is 2. And 2 times 2 times 2 is 8. Right? So there are 8 different combinations in this list, right? I could have all of them be boys. I could have all of them be girls, right? My combination, I have 4 children, but my first 3 would have been this one right here. Girl, boy. That was my combination before I had my 4th child, right? Okay, now, given 4 children, we won't list them all out, but 4 babies. How many options like this are there for 4 babies?
16.
2 times 2 times 2 times 2, which is 16, right? There would be 16 lists of like 4 like that, right? It would be like boy, 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 or girl, 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 right? And then I would have every combination of boys and girls in between those, right? But there would be 16 in that list. Does that make sense? Okay. Same thing for heads and tails. Heads and tails and boys and girls would be exactly the same because we're assuming that there's a 50-50 shot. Boys, girls, 50-50 shot, heads, tails, right? Even though I think, according to when this book was published, we are actually like 50.9% girl and 49.1% boy or something like that. But whatever, like that's according to the United States and maybe even the world. I don't know when this book was published. It says it somewhere. I think it's in this section. It says, even though boys and girls are not equally likely, it's actually this much for boys. I don't remember. But there's that, okay? So we're assuming it's 50-50. All right, let's talk about this right here. What can you have and what can you not have for probability? We'll ask here in a bit. Okay, so if I have a probability, and we're talking about probability as a, like, decimal, right? I could have a 0 probability, which means it's impossible, it's not going to happen. What are the chances of rolling a 7 on a dice? Not going to happen. You don't have a side that's 7, right? That would be impossible. 0. Right? What?
Sometimes you do.
I mean, on a fair single-sided dice, what's the chances of rolling 7?
Single-sided, you roll one.
Not single-sided, whatever it's called.
Seven-sided.
Six-sided dice. Fair six-sided dice, whatever. Okay? If it's close to 0, it's unlikely. Did you look it up? What did you get? Jace?
It's China.
It's China.
It's
China's
China.
the one that kills baby girls.
We're heavy on boys?
What?
Right now? Is that what you looked up?
No, he was looking at China.
I looked
Oh.
up what percentage of the Chinese population was girls.
They don't do that anymore.
Oh.
They used to, though. Yeah, I'm pretty sure they've put that. But they do. No. They do fine you if you have more than like 2 children or something like that. Because they're trying to reduce their population. They're like spreading too fast, right?
Yeah, we
So
did
like
that.
you get like a really very hefty fine if you have more than two children. Whether it's accidental or on purpose, I think you have to pay a fine. I don't know. Anyway, okay, if you have a probability that is like really close to 0, like a 0.03, that is very unlikely to happen, okay? Then we have a 50-50 chance, so 0.5 as a probability is a 50-50 chance. It is as equally likely as it is not to happen. Give me something that has a 50-50 shot. Heads or tails, boys or girls, right?
What if it lands on the side?
Well, that's whatever, okay? So, 50-50 shot. You can have a probability that is 1 or 100%, right? Give me something that's 100%.
To get heads or tails.
To get heads or tails, right? Like on it, well, unless it lands on its side, like Remington said, whatever, right? Okay, heads or tails.
For the coin to land.
What?
For the coin to land.
For the coin to land, that's 100%. I mean,
What if you're in
you know, whatever. If you're in space, whatever. Okay, you guys are going to do all those things. If it's really close to 100%, it's likely, right? Do we know this? Okay? You cannot have, okay? I can remember, who was it? Cody Hubble. Do you guys remember Cody Hubble?
Yeah.
Okay, he was like graduated like oodles of years ago, like 4 years ago, something like that. And he sat in the front row, right where Kellen's sitting, except we were turned around because like the board faced it that way. And he said, wait a second, I have seen before where they'll say something that's higher than 100%. I'm like, no, probability only goes to 100%. It cannot be negative, goes to 100%. And he's like, wait a second, I've seen percentages higher than 100%. And I'm like, yes, you're talking about percent growth, okay? So let's talk percent growth really quick. Don't write this down, okay? But what is happening?
Like if something grows by 300%.
Yeah. If something's growing by 300%, it's tripling, right? Okay. So like, let's say this year, what is happening to my pen? Go away.
No, it's gonna be
This year equals, what the heck? Equals 200% growth. That means it has doubled from last year. Does that make sense? Okay, so that is percent growth and not a percent as a probability. Yeah?
Yeah.
Okay, so probability cannot be negative. Probability cannot be 100%. You guys have seen Mean Girls where she's like, and there's 108% chance that it's already raining. And she's like the ditzy one, you know? That's not a thing. Okay, that's not a thing. Okay, good? Probability, 0 to 100. Nothing in between, or nothing outside of that, okay? All right, with one birth, let's talk about simple events. With one birth, one girl is a simple event. Whoa. One boy is a simple event. I don't know what's happening to my pen. Okay, quit with that. Okay, then we start talking about 3 births, okay? That is going to be the result of 2 girls followed by a boy. When rolling a single die, the outcome of 5 is a simple event. Not a simple event would be with 3 births, the event of 2 girls and 1 boy. Okay, is not a simple event. They say because 2 girls and 1 boy could be girl, boy, girl, or boy, girl, girl, right? We are talking about like compound events, like it could happen a couple different ways, right? Sample space, we already said that, was the list of all possible outcomes. All right, go to example.
Wait, can you explain how the second bullet point and then the first of the not simple event? That doesn't make sense. 'Cause that's the same thing, right? 3 birds, 2 girls, 1 boy.
Because there's only one way that that's going to happen. 2 girls followed by a boy. Girl, girl, boy is only one occurrence in that set.
Yeah.
So then the other one is talking about it could be.
It's
girl, boy.
compound. It's compound when you just say 2 girls, 1 boy in general. I don't care what order they're in. That's compound. Because it could happen multiple ways. Okay? All right, next. Go to the top of the next page. Shh.
Hey!
Jace, turn around. Top of the next page. When we're calculating probability, it is the number of times something has occurred over the total number of times. Okay? So like rolling a dice and getting a 3, we do the number of times that it was a 3 over the total number of times that I have rolled the dice. I don't know why my pen is doing that. Okay? Go over here for notations. It says P is the notation that they use for probabilities. So if they ask for, let's go P of odd. Okay, write this down off to the corner.
What just happened?
P of, I don't know why he's doing that. P of odd for a dice. What's the probability? This is the notation that they'll use. This is the probability of odd, right? For a dice is going to be 3 out of 6. I don't know what is happening to my pen. What's happening to my pen? I switched pens because the tip was broken off. My child broke the part that you screw in. It's like stuck in. No, I just lost the top. Where did he go? Oh, I got him.
Probably just bit the tip off.
She didn't even bite it. She broke it. And it's stuck inside of the other pen. So I got to fix it.
Do it.
Okay, hold on. I got to have him connect. Okay, there we go. Probability of odd. 3 out of 6, which is 50%. Okay? Now, 3 out of 6 is 1/2 or 50% or 0.5. And you're going to ask me when you do this homework assignment, which one do I get? Which one do you give me? Half, 50%, 0.5. Any of them. I don't care.
That's a long head.
So you can choose whether you want them as fractions, decimals, percents. I don't care. Got it?
Get scissors.
Yes, yes. Okay. Let's go to. I don't want to talk about the law of large numbers yet. Let's go to example 3. Find the probability of dying when making a skydiving jump. Okay? In a recent year, there were this many skydivers and 21 of them resulted in death. That's still too high for me. Okay? I want to find the probability of dying when skydiving. So we want die
It's not
over
very high.
total. And we convert that to a, I don't know what is happening. We convert that to a decimal.
What do I do if my calculator gives it to me in scientific notation? Do I get it?
Go out of
You
science.
convert
Probably fix it.
But it says it's in normal.
Oh, what are you doing? What are you doing?
0, 0, 0, 0, 0, 7.
That's nice, I fixed.
21 over 3 million. Why are you doing this?
That's a sign to quit.
I don't know why it does that.
Shucks.
Shucks.
I going skydiving when I turned 18.
Ugh, not me.
On that day.
No.
Yeah.
John Lawton said he's gonna go with me. He's been 3 times.
Okay, 21 over 3, whatever. Okay, what do you get? What do you get as a decimal?
There's 0, 5. So point.
1, 2, 3, 4, 5, and 7.
From what, the one place
Ugh.
we were in?
I'm trying, folks. There we go.
When you write.
I'm not.
From some practice.
Okay, 5 zeros and a 7. That is the probability of dying. That's still too high of a number for me, I think.
How do I get my calculator out of scientific notation?
Go to-
How do you get it out of scientific
It
notation?
says it's on normal, but it gave it to
Go
me.
to mode.
Yeah, you just messed up.
You know, now you know what I mean.
But hey, like Coffee said, you only need 2.
I did.
This is one of the 2.
I know. I jammed both of these. He's like, well, you only need 2.
Which is the weirdest thing.
That don't help, Coffee.
That's the let's go.
Yeah, that was last time. I watched my show. It's been.
Let's go.
Huh. Someone bit it off.
Hurt.
Oh, that got hurt.
Still doing it. Why is he still
like
normal.
not in charge of
It's
it.
not science.
Show this.
That's not what I want.
That coach was laughing about it.
Tommy, can I go to the
Let
bathroom?
me
No.
look it up. I'll look it up. Okay, here's what I want you to do. We're gonna stop
Ruining my day again.
because our attention span is dwindling.
He'll be crooked.
Go to the homework and do. I don't know. Do 5 through 12. These first ones. On your homework. Go.
Alright.
Okay.
Which of the following are probabilities?
Which of the following can represent probabilities?
Not the negative one.
Not the negative one.
Not the 250.
Okay.
And not the
What about
2.017. And
What?
Yeah, do ratios count? Can we do ratios?
What you mean? Which one?
like 7
Like
3.
7 to 3, 5 to 1.
7 to 3 is technically odds and not probability.
Same with 50-50.
Same with 5 to 1. 50-50 is a probability. That works.
Idiot.
7 to 3 is an odd.
Dummy.
But I think 7 to 3 will work. I think they count it as probability. 7 to 3, just FYI, as a probability would be 7/10. Did you know that?
So do you want us
Yes.
to?
So you can go ahead and say yes,
You
that's
look
true.
at
That will
7.
work. Okay? 5 to 1 would be 5/6. I don't know what's wrong with my pen. I'm out today. Okay? So, yeah, there you go. Okay, go. Go do. Go bye.